Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 1 from module 6, Complementary and Supplementary Angles. So the opening exercise says, as we begin our study of unknown angles, let us review key definitions. So here it says two angles, angle AOC and angle COB, with a common side, which is ray OC, are blank angles if C is in the interior of angle AOB. So what they're saying is if I have an angle here, and this is A, and this is O, and this is B, okay, when two lines intersect, any two non-adjacent angles formed by those lines are called blank angles or blank angles. Okay, so what they're saying here now, two lines intersect. So if I have this line right here, and then I have another line right here, okay, so we have this angle and this angle are adjacent, but this says when two lines intersect, any two non-adjacent angles. So a non-adjacent angle for this would be over here because this angle's adjacent and this one's adjacent. So non-adjacent are opposite each other, and those are called vertical angles. And then it says or, and it's vertically opposite. Okay, next one. Two lines are blank if they intersect in one point, and any of the angles formed by the intersection of lines is 90 degrees. Two segments or rays are blank if the line containing them are blank lines. Okay, so it's one word that fills in all three blanks here. The two lines are blank if they intersect in one point. So we have a line. We have another one that intersects in one point, and any of these angles formed by the intersecting lines is 90 degrees. So this one intersects like this, okay, intersect at one point, and they said any angle is 90 degrees. Then the two lines are perpendicular. Okay. Complete the missing information in the table below. In the statement column, use the illustration to write an equation that demonstrates the angle relationship. Use all forms of angle notation in your equations. Okay. Okay, so it says adjacent angles. Abbreviation. Angles add. It says the measurement of adjacent angles add. Illustration. Angle BAC is adjacent to angle CAD, and angle BAC plus angle CAD is the whole angle BAD. So we're naming these angles in here inside here with these little letters here. So angle A plus angle B, and this whole arc means the whole thing C. So what I'd say is A plus B equals C. Okay. Vertical angles. Vertical angles have equal measures. So we're going to say VERT period and then the angle symbol. And I like using an apostrophe S. And I meant to put an apostrophe S here. So let me just fix that. Angles add. Okay, so this one's vertical angles. Vertical angles. And let's see, I don't really want to use ADD for this, but measures of adjacent angles add. Well, let's just leave that for now. It's really strange how they're wording this. That's why I'm stumbling across it. So now it says vertical angles have equal measures. So here I'd say, well, here's angle A. It's vertical to angle B. So A equals B. Okay, this says angles on a line, so we use the angle apostrophe S symbol, and it's angles on a line. So the other thing we can really abbreviate there is the word angles. So angles on a line, and it says if the vertex of a ray, lies on a line, which is right here, but the ray is not contained in that line. In other words, here's line AD, here's line BC, and the vertex is at B, but ray BC is not on BD or AB or AD, so it's going in a different direction, in other words. Then the sum of the measures of the two angles formed is 180 degrees. So here we have angle A plus angle B, and they add up to 180 degrees. That's angles on a line. Okay, now angles at a point, and there is no abbreviation for that except for the word angles at a point. Suppose three or more rays with the same vertex separate the plane into angles with disjointed interiors. Then the sum of all the measurements of the angles is 360. So all that is saying is we have three rays going in opposite directions from the same vertex point. Then each angle that it forms, no matter how many there would have to be 2 or 3 or 4 or 5, depending on how many number of angles. You add them all up and they always equal 360. So in this case, A plus B plus C equals 360 degrees. Okay, angle relationship, complementary angles, definition. Okay, bring that in typed form. Okay, the definition of a complementary angles is if the sum of the measurements of two angles is 90 degrees, then the angles are called complementary. Each angle is called a complement of the other. So here are two examples off to the left here. Two angles can be complementary. They could be adjacent and complementary, or they could be totally separate and not even be at the same vertex. They could be separated any way. That this does not even have to be parallel to this. There's two different angles somewhere in space. If they are a sum of 90 degrees, then they are complementary angles. Okay, supplementary angles. If the sum of the measurements of two angles is 180 degrees, then the angles are called supplementary. Each angle is called a supplement of the other. So we have two examples here. This here is two angles on a line, or yes, angles on a line, or supplementary angles, or we could also call these a linear pair. Okay, so in other words, they are sharing one line, and then there's a ray coming off, so the two angles are adjacent, forming a straight line. 120 plus 60 degrees is 180 degrees. Or the two angles do not have to be at the same vertex point. This could even be rotated a little somewhere in space. As long as their angles are adding up to 180 degrees, they are supplementary angles. So exercise 1 says, in a complete sentence, describe the relevant angle relationships in this diagram. Write an equation for the angle relationship shown in the figure and solve for x. Confirm your answer by measuring the angle with a protractor. Okay, so when they're looking at angle x, you need to be careful with how you read this. Angle x is not this angle right here, but this angle is 90 degrees. Angle x is this angle. So it's not, the diagram is not drawn well, but that is angle x. So what I would say is angle x and angle 22 degrees are supplementary. Okay, which means they add up to 180 degrees. So now if I want to solve this, I would say x degrees plus 22 degrees equals 180 degrees. So this is where our algebraic equation setup that we learned earlier in the year is going to come in handy. So now we want to get x by itself. 22 is being added to it. The inverse of 20, no, addition is subtraction. So we are going to subtract 22 from both sides. These cancel, they're additive inverses. And we get x degrees equals 180 minus 22, which is 158 degrees. Okay, example 2, or example 1. The measurement of two supplementary angles are in the ratio of 2 to 3. Find the measurements of the two angles. So if I just drew a quick sketch of this, and I had a straight line here, and then I had another ray coming off of that at this point here, I have two adjacent angles that form a straight line. They're angles on a line. They're supplementary angles. And their ratio is of 2 to 3. So I'd call this 2x and call this 3x. Whenever we have a ratio, we just put a variable times that ratio value. And that is our model. So since they're supplementary, then we say 3x plus 2x equals 180 degrees. Combine like terms, 5x equals 180 degrees. And that means multiplication, and the inverse of multiplication is division. 5 divided by 5 is 1. X equals, 5 goes into 18 3 times, with a remainder of 3. 5 goes into 36 times. So x equals 36 degrees. So it says find the measurements of the two angles. So if x equals 36, then 3x equals, let me do it over here. 3x equals this portion here. So what we're going to do is just, let me just show it as multiplied by 3. So 36 times x is this angle. So it'd be 36 times 3, 18, and 3 times 3 is 9, plus 1 is 10. So this portion is 108 degrees. And then if I take 36x, that should be 3x. Let me do this again. My apologies. Okay, so we have 3x. Substitute in the given x. 3 times 36. And that is 108 degrees. And if I do the same on the other side, 2x is the angle. 2 times x, which we found to be 36, which is 72 degrees. So that's this angle here. And the blue one is 108. And you should always check. And definitely 108 plus 72 does add up to 180 degrees. So exercises 2 through 4 feed off of these examples. So please go ahead and try them. Pause the video, come back and see how you did. Okay, here's another ratio. 3 times that in a pair of complementary angles. There's a key word right there. The measurement of the larger angle is 3 times that of the smaller angle. Find the measures of the two angles. So it's a ratio of 3. It's a ratio of 3 to 1. Complementary means 90 degrees. Angles that add up to 90 degrees. So I would say 3x plus 1x equals 90 degrees. 3x plus 1x is 4x equals 90 degrees. Divide by 4, divide by 4. And x equals 4 goes into 9 twice with a remainder of 1. 4 goes into 10 2 times with a remainder of 2. 4 goes into 25 times. So x is 22.5 degrees. So one angle is 22.5 degrees, and the other one is equivalent to 3x, and that would be 3 times 22.5, and that is 5 times 3 is 15, 3 times 2 is 6, plus 1 is 7, and 3 times 2 is 6. So the other one is 67.5 degrees, and if I take that 22.5 degrees and add it to 67.5 degrees, I get 90 degrees. So my answer is x is 22.5 degrees, and the 3x, okay, the 3 to 1 angle, the other angle is 67.5 degrees. Okay, number 3, the measure of a supplement of an angle is 6 degrees more than twice the measure of the angle. So we're talking about supplementary, which are 180-degree sums. 6 more than twice the measure of an angle. Okay, earlier in the year, the word more than means to add. And when we see the word more than, less than, greater than, we always do right to left reading. So twice the measure of the angle. So let's call that 2x plus 6. So the measure of a supplement of an angle is 6 more than twice the measure of the angle. So that'd be, the angle is x. So we're taking twice that angle plus 6 plus the original angle. So this is the supplement to this. That's confusing to you. And that adds up to 180 degrees. So I'm going to combine like terms. 2x plus x is 3x plus 6 equals 180 degrees. Subtract 6 from both sides, and we get 3x equals 174 degrees. And we divide by 3 on both sides, and x equals 3 goes into 17 5 times with a remainder of 2, and that will be 58 degrees. So angle 1 equals 58 degrees. Angle 2 equals the 2x plus 6, which is 2 times 58 plus 6, which is 116 plus 6, which is 122. So angle 1 is 58 degrees, and angle 2 is 122 degrees. Those add up to 100. Okay, next problem. The measure of a complement. Right there, complement means adds up to 90 degrees. Of an angle is 32 more than 3 times the angle. So the angle is x. Plus, and then we're going to do 32 more than 3 times that angle. So it's going to be 3x plus 32 degrees equals 90 degrees. Combine like terms. 4x plus 32 equals 90 degrees. Subtract 32 from both sides, and we get 4x, these cancel, equals 90 minus 32 is 58 degrees. Divide by 4, and x equals 14.5 degrees. Okay, find the measurement of the two angles. So angle 1 equals 14.5 degrees. Angle 2 is 3x plus 32. And x was 14.5 degrees. So when I multiply that, 5 times 3 is 15, carry the 1, 4 times 3 is 12, plus 1 is 13, carry the 1, 3 times 1 is 3, plus 1 is 4, 43.5 plus 32 is going to be 5, 3 plus 2 is 5, and 4 plus 3 is 7. So it's going to be angle 2 is going to equal 75.5 degrees. Okay, example 2. Two lines meet at a point that is also the vertex of an angle. Set up and solve the appropriate equation for x and y. So we got a lot of stuff going on here. We have an angle at a point. So there's 1, 2, 3, 4, 5, 6 angles that would add up to 360 degrees. But if you look right here, in order to find y, we can use this portion. That is a 90-degree angle because it's the right angle there. So this angle here, that's 16 degrees, and the angle that's called y is right here. That is complementary to 16, or it's a complement of 16 degrees because they add up to 90. So I would say angle y, actually let's not use the angle symbol, let's just say y plus 16 degrees equals 90 degrees. Subtract 16 degrees from both sides, and we find y to be, cancel, 74 degrees. So this is 74 degrees, and that's just this piece here, not counting the 16 degrees. Okay, so now in order to find x, if you look, let me get this out of the way. I'll leave it. I'll do a different color. This is 90 degrees, and x is going from here all the way to there. So if this is a straight line, and this is a straight line, then this is 90 degrees here, and then we have to add this to it. But we've already found this piece here to be 74 degrees, so this whole thing is 90 degrees right here. If I draw this up and over like this, that green angle is also 90 degrees, and y is 74, so therefore this has to be also 16 degrees because it's the same as this, making 90. So if this is 90 degrees and x, and the angle that we're looking for x to be this whole thing, okay, is going to be 90 degrees plus that 16 degrees is going to equal x. So 90 plus 16 is 106. And that is the measure of angle x. Okay, there is another way I could also do that. There's always more than one way to do a problem, especially in these diagrams. But let me show you a different way. We could also have done this. We know that this is a straight line. We know that angle x is here, and we already found y to be 74 degrees. So a straight line is 180 degrees. So I could say x plus y equals 180 degrees. These two angles, x and y. So x is our unknown, but we found y to be 74 degrees. And then if I subtract 74 from both sides, and this cancels, and I get x equals 106 degrees. So as you can see, either way you do it, you get the same answer. This was representing a complementary angle though, and the red one was representing how to do it with a supplementary. Okay, that is the end of lesson 1. Go do your problem set. And oh, by the way, smash the